All right, so welcome everybody to the fourth session of pre-chemistry workshop. Let me just start with asking you that what do you guys remember? What did we discuss last time? Where did we left off? Anybody?
I think we left off at you were talking about group 4A and about shared electrons, and you talked about I think you're talking about something with the same protons but different neutrons. Looking back
Yes.
at my notes, isotopes, how it was, yeah, and then yeah, so that's where we left off, and I think you went a little over on the little diagram with the dots.
Yes.
Something about that. I didn't understand that, but like
Lewis structure.
Yeah,
All
that
about Lewis theorem.
yes. So that was, thank you for saying that. Again, that was a bit out of the topic, but because I have already discussed that, so let me just start with saying how does Lewis symbol and structure work. Very basic information. Of course, we had to go a lot more in detail when you're going to learn this in the lecture, but I can just give you like brief information on that before we talk about ionic compound and the molecular compound. All right. So first of all, what is the Lewis symbol, right? So we call this as a Lewis symbol. The Lewis symbol is basically a presentation in which we just write a symbol for any element, right, which we already know, and we put number of valence electron around this symbol in form of dot. All right, so let me ask you one more time. Do you guys remember how many? All right, so let me ask you this. How many total number of electrons? So there is two different points. All right, so let me ask you first question. Okay, let me start with the basic information. Atomic number. Can you guys tell me what is the atomic number for fluorine?
9.
9.
Everybody? That's great. Yes, you can just look at the periodic table, look at the box, look at the sequential number that goes up by one digit in every box. That is your atomic number 9. Yes. So number of electron would be what? Number of electron. If I'm gonna say how many electron are going to be there for fluorine?
9.
90.
Excellent, right?
No.
Why is that? Because it is an element. If it's just an element, not an ion, then we can say atomic number is equal to number of proton, also equal to number of electron, right? So yes, it is 9. But now the thing is that we know how this electron are arranged, right? We know the basic information, how they are arranged. So this is like a nucleus, then there is energy level, or we call this as a cell, right? So this is first energy level, or we can call first cell. This is your second energy level or second cell. The maximum number of electron, all right, max number of electron we can have in the first cell is 2. All right, so somebody has their microphone on. Would you please turn off? So it will be helpful for everybody to listen to me. Yeah, thank you so much. So max number of electron we can have in the first energy level is 2. Do you remember that? We talked about it yesterday,
Yeah.
Yeah. Yes.
right?
And
The
in
maximum
second is 8.
second is, yep, that's right. All right, so I hope you guys remember that. So in this case, when we have total number of 9 electron, how are we going to arrange them? We're gonna put 2 electron in the first shell, and we're gonna put remaining 7 electron in the second shell, right? For this example, for fluorine, we know that this energy level 2, or we can call this shell 2, is the outermost shell, right, which is also called as a valence shell. So this second energy level, we can call it as a outermost shell or energy level, or the other word would be valence cell. All right, we talked about these terms yesterday as well. So for fluorine, how many valence electron are there? So the number of electron we have in the outermost shell which is called outermost shell or valence shell, that is called valence electron. So in this example, because we have 7 electron in its outermost shell, we have basically 7 valence electron. Do you follow me?
Yes.
Yes.
All right, so fluorine have 7 valence electrons. All right, so what is the Lewis symbol? Lewis symbol is something that we just draw the symbol of an element and we represent how many valence electron that particular element has in form of the dots. All right, so because this is going to have 7 valence electron, we're just going to make a dot representing each electron. So this is 1 electron, this is 2nd electron, this is 3rd electron, this is 4th electron. I like to put 1 dot on each side, and then we're gonna make them in a pair if we have more. All right, so second, now we have 3 more to go. So we're gonna say 1 more here, 1 more here, and 1 more here. It doesn't necessarily has to be in this order. You can put it in any way you like. Okay, but basically you have to have only 7 dots around the symbol of fluorine. This together is called Lewis symbol. So when you draw the symbol for an element and you represent the number of valence electron it has using a dot, that is called Lewis symbol. Do you follow me, everybody?
Yes.
Yes.
Yes,
Yeah.
Professor.
Everyone, yes?
Yes. Yes.
Yes, Professor.
Excellent, great. Right, that there is another term that is called Lewis structure. Right, we are not going to discuss this in detail, but I can just give you one example. Lewis structure is what it means. When you have a compound, right, this is an element, you see this, right, this is an element, just one of the box from the periodic table. When you draw the electron around that element, it is called Lewis symbol. When you have Lewis structure, it means when you have a molecular compound. You remember we talk about the example which is water, right? In case of water, how does it work? They share the electron, right? So this is the
Yeah.
structure, right? You remember this? We talked about at the end of the yesterday's session, right?
Yes.
So because this is a compound, right? This is what? Water, H2O. It is a compound. So when we draw the kind of similar Lewis structure for like Lewis symbol, when we put all of those together, right? Hydrogen, oxygen, and hydrogen, how they are attached to one another, that is called Lewis structure. There are a few rules that you need to follow to come up with the right Lewis structure, which you can learn in the lecture later on. All right, but do you understand the difference between structure and the symbol?
Yes. So it's only
Yes.
for molecular, not ionic, right?
Yes, when we talk about Lewis structure, this concept only apply to the molecular compound, or we can call molecular compound, or it can also call as a covalent compound. All right, it's the same thing. It's like a, sometimes we use molecular compound as a term, sometimes we use covalent compound as a term. So this concept only apply to molecular compound. Yes. Everybody follow me? Everybody understand?
Oh, yes. Okay.
Yeah.
Okay. All right. Okay. Before I erase this, I just want to point out one more thing. Simply by looking at the group number, you remember, this is the way I like, right? 1A, 2A, then 3A, 4A, up to 8A. Simply by looking at this group number, you can find out how many valence electron, number of valence electron are there, right? Number of valence electrons for any element. For fluorine, let me ask you this, which group number it is in terms of A?
7.
7.
7A. So didn't we come up with the 7 number when we draw the structure?
Yes.
It is, right? So you don't have to come up with this kind of structure. You don't even have to imagine this. This is for your understanding. Simply by looking at the periodic table, looking at the group number, the label like 4A, 5A, up to 8A, you can see that which group it is present in. Just by simply looking at it, you can determine how many valence electron are going to be there. All right. By looking at the atomic number, you can determine what is the total number of electron. So that is a difference. All right. So keep in mind, to find out total number of electron, you need to look at the atomic number, which tells you how many total number of electron does that element has. But if you need to find out what is the valence number of electron, then you need to look at the group number. Everybody understand this part?
Yes.
Everyone, again, do you understand
Yes.
this?
Yes.
Yes.
All right, so I'm going to erase this. All right, and as I told you, we are going to focus on ionic compound and the molecular compound. So molecular compound is also known as a covalent compound. So I need to mention that here. So now what is the difference, what they are made up of? So first point, how can you identify, let's say if I'm just going to give you a structure, right? Let's say NaCl, or if I'm going to say H2O, how do you know if it's a molecular compound or ionic compound? All right. The first thing you need to know is look at the periodic table and you should be able to identify what are the metals and what are the non-metals. So you remember there is a zigzag fashion separation in the periodic table, right? In general,
Yeah.
right? That
Yes.
zigzag fashion, everything on the left side of that zigzag, that is called metal. Every element on the right side of this zigzag fashion is called non-metal. All right, so when there is a compound which contain metal and non-metal element, then it form an ionic compound. It only form an ionic compound when there is a one metal and like when there is a metal and non-metal element comes together. For molecular compound, there must be both non-metal. Do you follow me?
Yes, sir.
All right,
Yes.
so as long as you have one metal element uh, in your formula, you know it is going to be the ionic compound. If both of them are non-metal, then you know it is molecular compound. At this point, I just want you to remember that even like the exception is hydrogen. You remember this? Even though hydrogen is present on the left side of this zigzag fashion in the periodic table, it is the only one element which is considered as non-metal from the left side. All right. So these all are non-metal. Along with them, the hydrogen is also considered as non-metal. So in this example, if you see Na, where do you find Na? You will find Na in group number 1A. Right now, because you just may not be familiar with periodic table, I am not kind of asking you to find out this element, but I'm telling you right now. Okay, Na is present in group number 1A. Cl, the second element, it is present in the group number 7A. So this is going to be metal, this is non-metal. What do you mean? Metal, non-metal would be ionic compound. Make sense?
Yeah. Yes.
Is it a bond or
Yeah, there would be a bond, there is attraction force between them. Same like like when we married, right? We don't just kind of like we live together, we there is attraction, there is a bond, right? So same way there is a bond between Na and Cl. The bond is called ionic bond. We are going to talk about that in a minute.
okay?
All right. And in here there is a electro, like because they are sharing electron, so there is a bond which is called electro attraction. All right, so because of the electron attraction, they're going to stay together. All right, and that bond is called covalent bond. All right, in here, right, in the second example, water, we know hydrogen is non-metal, right? And oxygen is also non-metal because that falls in group number 6 right here. All right, so if there are both non-metal, you know this is going to be a molecular compound or covalent compound. Everybody understand this part?
Yes.
Yes.
Yeah.
Excellent. Because we just talk about the bond, let me just talk about this. The kind of bond that is holding this ionic compound together, that is simply called ionic bond. And the kind of compound that is holding this molecular compound together, that is called covalent bond. And because of that covalent bond, the compound can also be called as a covalent compound. So this is called type of the bond. Okay. So
It was just synonyms, right?
sorry,
It's kind of like a synonym.
kind of what?
Oh, never mind. I got it. Sorry.
I thought like you talking about notes.
No, I was thinking like it's like a synonym, like the like ionic
Oh
bond.
yes, synonym. Yes. Actually, it's not synonym, but we can use this interchangeably. Why? Because both kind of both way, even if we call it covalent compound or molecular compound, it represents the same category of the compounds. Yeah.
Thank you.
Yep. No problem. All right. Now we know how this ionic compound form. We know that there is going to be metal and non-metal. But it's not just that. We are going to have metal, which is always going to carry positive charge. So everybody please remember that. When we have metal and non-metal, that is called ionic compound. And in that case, metal will be the one which is always going to carry positive charge. It could be +1, it could be +2, it could be +3, right? The same way the non-metal is always going to carry negative charge. Again, it could be -1, -2, or -3. Make sense? Right? Right. And here, how they are forming, it is formed by, okay, so by sharing electron, right? That you know that. What they're going to do, the molecular compound, they are just going to share the electron. And in here, what they're going to do, metal is going to lose an electron, right? Loss of electron to make positive ion. And non-metal is going to gain of electron, right? Right, I'll say electron, so just to be clear, right? Electron, right? In on the covalent side, they are just going to share their electron, while in case of ionic compound, the metal element is going to lose the electron. Depending on how many it's going to lose, it depends on which group it is present in, and the non-metal is the one is going to accept it, right? So any ion with a positive charge, right? Any ion with positive charge, it has a particular name, right? That is called cation. All right, ion with a positive charge, we generally going to refer it as a cation. So this is called cation. While the ion with a negative charge, right? Ion that has negative charge, that is called anion. So if you come across this term, you should know what does it mean. All right, so if there is any ion which carry negative charge, we could call it as a anion. So in this example, NaCl, we can call Na is a cation and Cl is an anion. Is that clear?
Yes.
Yeah.
Everybody?
Professor, I have a question.
Yes, go ahead.
Where do you find the grouping when you were referring to 2A, 1A? I'm not sure where do I find that in the table.
Okay. So all right, let me just, I think, okay, one is called 1A. You know the group number, right? Where are they? Do you see the group?
No, I don't see that. I'm looking at the periodic table that you had emailed us.
Okay, so do you see on the top of the periodic table there is a number in the sequential order? There is a first row which says 1, 2, 3, 4, 5, 6 up to 18. Do you see that?
Up to 18. Yes, I see that.
Right. So in there is a one way to label those group. There is another way to label that group is this. So you can just write it down manually, right? The group number 1 is called 1A, 2 is called 2A, then is 13, that's called 3A, and you can go on. 14 is called 4A, right? Let's say 17 is going to be called 7A, and 18 is going to be called 8A.
Okay, so from 1 to 13 is 1A?
No, 1 is called 1A.
Okay,
2
1 is
is
1A. Mhm.
2 is 2A. Then you're gonna move on to 13. 13 is 3A.
13 is 3A. Okay.
All right. Then you're just going to continue 4A, 5A, 6A, 7A, and 8A. So 14
Okay.
is will be 4, 17 will be 7, 18 will be 8. Make sense?
All right. I understand. Thank you.
No problem. All right. So we did discuss the what is the difference between ionic compound and the molecular compound. All right. Do you guys have any question for me before I erase this?
No, Professor.
Okay. Okay. Excellent. Excellent. All right. So let me just talk about how we going to name this compound. At the moment, I just want to start with the molecular compound because that's the easy one. All right. So make sure you keep your handout handy with you. Like I have shared that handout and it has the rules that that you guys need to know. So let's just focus on the end, the last section of the handout, which says how you're gonna name a molecular compound, how to name it, and how to come up with the formula, right? So molecular compound. For ionic compound, there are more rules, so we need more time. So I just wanna, get rid of just wanna finish this first before we go in detail. So molecular compound. Again, what do you know about molecular compound? What is the most important identification that you need to have? Can you guys tell that? Anybody?
Non-metals and non-metals?
Yes.
Yep.
Right, that is the most important point you need to know. Molecular compound is always between non-metal and non-metal. That's the identification. Always remember that. Now when we're going to talk about non-metal, so let's just talk about the example like H2O, which is water. That is common name, right? But what we're going to learn in this example, we're going to learn how we exactly name the molecular compound. So let's say if we have CO, all right, there is one element which is carbon, second element which is oxygen. How are we going to name it? So always remember the first element in the molecular compound, you just name it as an element. So C, what do we call C as an element?
Carbon.
Carbon.
Carbon, right? We already know C stand for carbon. So yes, we're just going to put it down as a carbon, nothing else. And for the second element, you always use suffix. So everybody know what is suffix means,
Yeah.
right?
Yes.
Mhm.
You always use IDE as a suffix. Okay. For the second element, you always use suffix, which is IDE, and you also use prefix. I think I should have told you about prefix first. You always use prefix. What is the prefix? Prefix is going to be saying that, sorry, how many number of atom of second element you have. So in this example, when it says CO, it means there is one carbon and one oxygen. If it's one, you don't have to write one, right? CO means one carbon and one oxygen. But the rule that we are talking about is for the second element. So for oxygen, because it's one, we're gonna call it as a mono. All
Yeah.
right. If it's two, what do you think we can call the prefix? Di. All right. If it's three, I think everybody know now.
Try.
Try.
Right. Simple. Four,
Tetra.
Water.
tetra. Four, tetra. Five,
Beta.
penta.
Penta. Yeah.
All right. If you don't know, it's fine. You are going to learn
Yeah.
this, right? And if you don't know, you can just try to remember this right now. It's not that hard. Okay. First is if you just have one of this, it's called mono. Two then di. Three is tri. Four is tetra. Five is penta, and so on. Six is hexa.
Hexa. Yeah.
7 is hepta, 8 is octa,
Oct.
right? Octane, hexane, right? Like that. Octagonal, hexagonal, right? And so on. All right. Probably you're not going to go about 10. So I'm just going to stop this at this moment because I don't know to have more space. But you understand, right? You get the idea?
Yes.
Yeah. Okay, great. So if you're going to name the second element, you're going to use prefix. The prefix going to be what in this example? It's going to be mono. And you know this is oxygen, and you're gonna end that with id. It is going to be called oxide. So monoxide, because there are two O, we can just put it together like monoxide, right? When you put it together, we just simplify as one oxygen, like sorry, one O, right? So it is monoxide. Instead of oxygen, we are using ide as suffix, so oxide. You are going to learn this in your class, so don't worry. You of course need more practice, and when we're going to talk about the ionic compound, you will kind of listen to this many times over and over, and it will be kind of in your mind kind of easily. All right, so you can easily remember this, so don't worry about this. But do you follow me what I did?
Yes.
Yes, Professor.
All
Yes,
right.
Professor.
Yeah, excellent. So let's say if I'm going to give you this name, what do you think the name is of this
Carbon
compound?
dioxide.
Yeah, carbon
Right,
dioxide.
so
Yes.
first element, just the name of an element, which is carbon. Now we have two, means di, and again it's a oxygen, so oxide. Right, you may have heard about CO2 emission, the pollution that we have, right? So you may are aware of this. The same way, if I'm gonna give you something like this, N2O, right? So that is something you need to know. There is another rule that I haven't talked about yet. So for the first element, that is right, we're just going to call this nitrogen. That is right. For oxygen, how are you going to end it with? What should be the here?
Dioxide.
Oxide.
So nitrogen, we already named this, right? So for oxygen, what are we going to write this here?
Monoxide.
Dioxide is, oh, I see.
Mono, right? You agree?
Yeah.
There is just one oxygen, so we're gonna call it monoxide. Nitrogen monoxide is right, but what I said, there is another rule. The rule says when you have the first element which you have more than two atoms, sorry, I would say more than one atom. For the first element, when you have more than one atom, you have to specify this prefix. That's it. You just need to use prefix even for the first element when you have more than one atom. In this example, you have more than one nitrogen. So now you're going to use the same prefix for the first element. So what should be the actual name? What should be the actual name of this compound?
Dinitrogen.
Dinitrogen monoxide.
Make sense?
Yeah.
All right. Just that.
So
Okay.
if the previous, like the nitrogen, two nitrogen atom is, if it is two, then you put the prefix on the first noun, and if it's like the two oxygen, then you put on the second one.
Yes. So for the second one, right? For the second element, you have to use prefix all the time, and you are also using suffix all the time. All right. For the first element, you are not using prefix. Okay, let me just say that. You're only going to use prefix for the first element if it is greater than 1. If you have more than one atom of the first element, then you're going to use prefix. If it's just one element, you are not going to use prefix. Make sense?
Yes, bro.
Everyone?
Yeah.
Yes.
Yes. Excellent.
Yes,
Excellent.
Professor.
Yes.
Excellent. Thank you, guys. So let's see. I'm just going to give you a few more example, right? And I'm just going to see if you can come up with the answer. All right. So I'm going to give you a bit more challenging. Of course, it's not that hard. You know the stuff, the material has been given to you. You know the everything I have explained you, so you should be able to do this. Okay. I'm gonna give you maybe more. All right. Yeah, I think this should be enough. All right, what I'm gonna do, I'm gonna give you probably like 2 minutes, which I think is enough. It's not that hard. All right, I'm gonna give you 2 minutes to think about this, and then we're gonna discuss this. Okay, so do not share your answer until 2 minutes. If you have any question, you can definitely ask your question. Okay. At the same time, I would also like you to kind of, go through your handout, not even exactly right at the right moment, but once you finish answering this, go through your handout and just read the rules, all right? And see if it makes sense to you and try to remember them for the molecular compound. All right, so I know we haven't discussed that how you're going to use suffix ide for the second element. So I'm just going to say what that name is going to be just for the this two. Okay, so the F, you should write it as a fluoride.
Fluoride.
Yeah, just in case if you don't know, actually sometimes they use U and sometimes they don't. So I'm just not going to use it right now. Okay, and for Cl, it should be chloride.
Yes.
Right? This is something that you may not know, but you can do this. But other than this, you know the rules and see if you can come up with the right name. I'll give you 1 more minute to answer this. Yeah. Would you please mute yourself? Thank you. Okay, so I think it was enough time. So let's see what you get right. For the first example, SF6.
Sulfur hexafluoride.
Everyone, what do you think it is?
Agree with her.
Yeah, I agree with her.
Excellent, excellent, right? So S is sulfur. Just going to call this sulfur. F is of course fluoride, right? We can use fluoride. And for 6, we know that we're gonna use prefix, which is hexa. So hexafluoride, sulfur hexafluoride. Everybody understand this?
Yes.
Yes.
All right, excellent. All right, for the second example,
Carbon tetrachloride.
excellent, excellent, right? The first one is carbon, so of course it's going to be called as carbon. Chloride, I told you that it is going to be called chloride. And because there are four, we are going to call it tetrachloride. All right. And the last example, N2O5.
Nitrogen.
Dinitrogen pentoxide.
Dioxide.
Excellent, right? Di, because there are two, right? We have to use prefix for the first element if it is more than one atom. So dinitrogen, we're gonna just name it as an element. Then because there are five, we're gonna call it penta. And because it's oxygen, so I'm just going to call it pentoxide. All right, so it's not pentoxide, but okay, let me just erase that.
Professor?
Yes.
So instead of, so anytime we see the O instead of oxygen, it's oxide?
Yes, if we are talking, yes. So if it's a compound, right, and it's not like always for the oxygen, we are going to talk about some exception. But yes, if we are talking about the molecular compound and the second element is your oxygen, then it is always going to be oxide. Yes.
Okay, thank you.
Okay. And when we're going to talk about molecular ionic compound, I can explain you the exceptions. All right.
Professor, are there any more that end with the that you would have to change to the ide, like oxygen? Is there any more?
Yeah, all of this, right? All of the non-metal, if you have on the right, like on as a second element, it is going to be oxide. I'm sorry, IDE. So let me just erase this one more time and let me show you. So if right, so if it's nitrogen, that is called nitride. If it's oxygen, it's going to call oxide. If it's fluorine, going to call fluoride. If it's chlorine, you're gonna call it chloride. If it's fluorine, chlorine, bromine, called bromide. And we are going to talk about that when we're going to talk about the, if it's iodine, iodide.
So then all non-metals end in the ide. Does that include the noble gases as well, or it doesn't change?
Again, for noble gas, generally they do not make the molecular compounds, so you're not gonna see them.
Okay, thank you.
Yep. All right. So when you have an like nitrogen, oxygen, fluorine, chlorine, bromine, iodine, which is non-metal on the as a second element, this is what you're going to use. And like I think you guys know what is the actual name of this element. If you don't know, please look at the periodic table. All right, this is called nitrogen, right? This is called oxygen, this is called fluorine, right? So for this these four element are part of group number 7A, and when you name them, it end with INE, right? Fluorine, this is chlorine, this is bromine, and this is iodine. So for this, I can tell you this, that you're just going to replace INE with IDE. All right. So when you have, for example, chlorine, if you replace INE with IDE, it become the suffix, right? Chloride. That's what you have to do. For nitrogen and oxygen, it is a bit different, right? We cannot just exactly say that this is the four letter that you need to replace, but this is just something that you gotta keep in mind. All right. So oxygen will be called as oxide, nitrogen will be called as nitride. If it, in case if you have carbon, it's going to be called carbide. But you're not going to see this in this course. All right. You're not going to see the carbon as a second element. So don't worry about this. Is that clear?
Yes.
Everyone?
Yes, Professor.
Excellent. Any question? Okay.
No, Professor.
So remember the naming molecular compound and writing the formula, you can just do the opposite and you can write the formula, right? I'm not going to explain you that right now, because I think naming ionic compound is of course more challenging. There are many rules that you need to remember. So I think I'm going to focus more on that. Okay. But I'm pretty sure that you can do the opposite as well. If I give you the name, you should be able to come up with the chemical formulas. All right. So I'm just gonna Any question before we move on from the molecular compound? Anybody do not understand any part of this?
No, Professor.
No, Professor, we just need a little bit more practice and review the notes, and then we'll get better. I think so.
Okay. I completely agree with you. Okay, great. Thank you.
Thank you so much, Professor.
Yep. All right, so now we are moving on to the ionic compound. Very, very important. All right. And of course, this is challenging. I'm telling you that, right? It is challenging. All you need to do is practice, practice, and practice. It's not hard as long as you can remember few rules. All right. So first of all, how can you identify if it's an ionic compound? Anybody?
Metals plus non-metals.
Yeah.
Excellent, right? It has to have one of the metal element, right? And the other one would be non-metal. Then yes, we can say this is an ionic compound, right? Very simple example for ionic compound, right? We know that this is NaCl. It is an ionic compound. When you have to name the ionic compound, there are different rules. All right. So first of all, let me just talk about this. Na, in ionic compound, you always have two ion. One is called a positive ion. The second one is negative ion. Positive ion is also called as cation. Negative ion is called anion. Everybody agree?
Yes.
Right?
Yes.
Metal element always form cation, non-metal element always form anion. Do you understand this?
Yes.
Yeah.
Right.
For metal element, when you name them, right, you just simply name as an element, right? So there is nothing new or nothing different than what we just talk about in the ionic, in a molecular compound. So name it as an element. All right. So for that, all you need to know is what is the name of that first metal element. Do you follow me?
Yes.
Professor.
Right. But there are there is one addition to this. Beyond writing the name of the element, you also has to write Roman numeral, all right, for certain element. What are those certain element? It is the small area of the periodic table. You remember we label it as 1a, 2a, and then we move on to the 3a on the other side. So the middle section of the periodic table, which is in a smaller area, all those element, right? Let me just draw that here. Right, in general, like very brief, it looks like this, right? So this portion of the periodic table, which we did not label as a for group, this is called transition elements. What does it mean? It simply means that these are the element which can carry more than one charge. What I mean, I simply means that, let's say if we talk about Na, what did I say? Because it is in group number 1a, this is always going to be +1. Mg, because it is in group number 2a, it is always going to be +2. Aluminium, because this is in 3a, always going to be +3. That rule does not apply to this transition element. Why? Because for Fe, it is one of the element from the transition section of it. Fe can have +2 charge. Also, it can have +3 charge. All right. Same way for copper, it can have +1 charge, or it can also has +2 charge. All right. There are many element in this area of the periodic table which can have more than one charge. It can be +1 or +2. It could be +2 or +3. All right. That's why we call this as a transition element. Okay. And whenever we talk about the transition element, we just need to write a Roman numeral. So for example, if we're going to talk about Fe +2, right? What we're going to call this? Fe is basically called iron. Because in that example, it is carrying +2 charge, we are just going to write a parenthesis and Roman numeral, which is says 2. We need to specify what charge is carry if an element can carry more than one charge. If element cannot carry more than one charge, we do not need to specify. For example, NaCl, we are just simply going to call this as a sodium chloride, because sodium cannot have more than one charge. It is always going to be +1. Do you understand?
Wait, so only for transition metals does the Roman numeral apply?
That's right.
Okay.
All right. I am also going to share more detail handout on this. I know that we are going to conclude this session today, but like the workshop today, but I will still share more detailed information on this, that which element carries what different charge and how you can identify them. All right. Not all the transition element we need to know, but there are some that you need to kind of have handy or remember. All right, so iron is one of them. In other case, right, let's say if iron in the molecule, okay, let me just give you an example. Fe, okay, FeO. All right, should I say FeO? Yeah, I think I can say that. Yeah. All right. FeO. In this example, it is going to be called iron 2. Why? Because in this chemical formula, iron is carrying +2 charge. I'm going to explain you why or how. All right. If we have something like this, we have to call this as a iron 3. Why? Because in this chemical formula, it is carrying +3 charge. Okay, so just remember the first element, which is a metal element, you're just going to name it as an element. Also, if it's a transition element, you just need to write a Roman numeral. Otherwise, you don't have to write a Roman numeral if it's anywhere from group number 1A, 2A, or 3A. Do you remember this?
Wait, why did you write FeO again?
Yeah, we are going to talk about the name, but yes, this is
Okay.
FeO. Right, we are going to learn how to exactly name these molecules, but this is just an example to show you how we're going to write a Roman numeral. Do you follow me?
Yes.
Yeah.
All right, so at this point, right, in this area, if it's a transition element, you have to write a parenthesis and write a Roman numeral. Do you understand? All right, so this is going to be the name of the metal element. If it's a transition element, then you have to write a parenthesis and write a Roman numeral, and then we are going to write the non-metal part of it. All right, so this is the general format of writing the name. Now we are going to talk about, do you understand this part, everybody?
Yes, Professor.
No.
Yes.
No.
No?
This part you just did, I don't understand.
Okay, let me just erase this and quickly revise this, right? Again, if you do not understand that, you can definitely reach out to me later on, but I'm going to explain you one more time. All right, so let's say Fe2O3. All right, let me just give you a simple one. All right, in this case, copper oxide. So if you have to name this, I haven't explained you all the rules, so I cannot explain you how I came up with the name, but I think everybody know how we're gonna name NaCl. Na is a metal element. We're just going to write it as a sodium. Cl, it is a non-metal element. We're gonna write it as a chloride. All right, I'm gonna explain you how and why we are going to write them as chloride later on, but this is the name of an formula, right? NaCl, the name of this compound is sodium chloride. In the second example, the name of this compound should be what? In this case, Cu is a metal element, oxygen is a non-metal element, so copper is going to form a positive charge and oxygen is going to form a negative charge, right? For metal element, Cu is a copper, so we're just going to write simply as a copper. That is the name of an element. But I know in this formula, copper is carrying +2 charge. I'm going to explain you how do you identify that, but I still need to explain you more stuff before I explain you that. Okay, so this is going to be, in this case, by looking at the chemical formula, you can determine what is the charge on a copper. all right, which I'm going to explain later, but at least for this moment, I'm going to say copper is carrying +2 charge. So I'm going to write parenthesis, write a Roman numeral 2, and then I'm going to end that name with oxide. So this is how we can write the name. Do you follow this part?
Yeah.
How to write the name
Yes.
of a positive ion or cation. Do you follow that part?
Yeah.
Yes.
Yes, excellent, right?
Professor, I also
Yeah.
have a question.
Go ahead.
We also can call it like cuprous oxide.
All right, so you say cuprous, right?
Oh yeah, cuprous. Yeah.
Yeah, so actually, I do not like to use those common name. That is actually called common name, right? Uh, I think none other faculty in this department going to use that common name. But if you say it, it's not incorrect, right? It is good to stick with the this
Right.
kind of name, right? When you
Yeah.
say copper 1 or copper 2, that make a lot more sense, right? But if you say cuprous, it's not incorrect. Yes.
Is there a reason why the first one doesn't have any Roman numerals?
Yeah, I told you, right? Sodium does not carry more than one charge. It is always, always, always +1. So you don't have to write a Roman numeral. In copper, copper can have either +1 charge or +2 charge. Because it's carrying two different charge, you have to specify that what charge copper is carrying in this chemical formula. Make sense?
Yes.
Right? So all the element in group number 1A, 2A, and the 3A, especially the aluminum, you do not have to write, no need to write Roman numeral. Okay, if and only if it is a transition element, then you have to write Roman numeral. Make sense?
Yes.
All right, so that's how we know how to name a cation, right? So there is only two rules. Either you just name it as an element, that's the first rule. If it's a transition element, again you are going to name it as an element, but in addition to that, you are also going to point out what is the charge on that cation, because we know it can carry two different charge, right? So we need to specify that what charge this particular cation is carrying in this particular formula. That's it. Make sense? Sodium will always carry +1 charge, so you don't need to say it, right? Do you follow me?
Yes.
Excellent, right? So moving on from this to see what are the different name for the anions. All right, so we're going to learn how to name anion, and for naming the anion there are many rules. All right, I'm going to start with a simple one.